All right, it's time to flip your world upside down. We are going to get away from degrees, and we're going to get into what we call radians. So in order to do that, we want to think about the distance traveled around the circumference of a unit circle. So this is kind of the most important thing, okay, when we think about what a radian is. So a radian takes the distance of a radius of any circle. So what a radian is, it's the distance of a radius of any circle, and it shifts it to be on the circle. It calculates like the distance of the radius. So for example, if I took this radius right here and I bent it and put it right on the circle to make an arc length, it would, if I started it right here and I started to bend it, it would go, somewhere about to like there. That would be an arc length of r, right? So I would say this arc length is whatever the r was, whatever the radius. So if the radius was 5 inches, that arc length would be 5 inches. This, for 1 radian, it would be 5 inches. And to kind of fully comprehend how our radians work on a circle, we have to understand what the circumference of a circle is. Remember, to calculate pi for any given circle, we take the circumference and we divide by the diameter, right? Any circle. I could take the circumference of the circle, divide by the diameter, and I would get pi. Well, we're paying attention to the radius here, not diameter. So let's switch diameter to 2r. Right? Because if I doubled the radius, I'd have the diameter. And let's solve this guy for the circumference. So if I multiplied 2r on both sides times 2r, circumference can be found by taking 2 pi r, or 2r pi, or however you want to write it, 2r pi. So if I try to answer this question on the bottom, what is the circumference of the unit circle? Well, the circumference in radians would be what? Well, it's basically saying how many times does r go into the circumference? How many times does that distance of the radius go into the circumference? Well, it goes into it how many times? 2 pi times. So basically, this distance of the radius, if I multiplied it by 2 pi, or like, 6.28, approximately 6.28, it would take 6.28 of these radians, so there would be a second one, a third one, a fourth one, a fifth one, a sixth one, and 0.28 of a radian of the radius distance to get all the way around the circle. Okay, and I'll show you a cool animation of that in class, but basically a radian goes around a circle 2 pi times, right? So that radius distance multiplied by 2 pi would give you the circumference of the circle. So knowing that, we're going to find the radian measure of each of these points. So for example, this could be 0 or something we'll look at in just a second. But if I went 90 degrees, what would that be in radians? Well, let's think. It takes 2 pi to get all the way around a circle, right? So it takes 2 pi radians. So that would be my other. It takes 2 pi to get all the way around the circumference. So how much would it be to get halfway around a circle? Well, half of that. This would be pi amount of radians to get halfway around a circle. All right, because if I took the radius and I started to bend it, there's 1 radius or 1 radian. There'd be a second, there'd be a third, and it'd be about 0.14 of a radian to get there. So if I wanted to get to my original, to just go 90 degrees around the circle, well, that would be half of this distance. So it would take pi over 2 radians. Okay, so these are all in radians right now. Pi over 2 radians. What about down here at 0, -1? What would this be? Well, that would be in between pi and 2 pi. So that would be 270 degrees, which is 3/4 of the way around the circle. So it's really 3/4 of that 2 pi. Well, if I took 3/4 of 2 pi, I would be at what? 6 pi over 4, which is also known as 3 pi over 2, like 1.5 pi. All right, so it's like half a pi, pi, 1.5 pi, 2 pi to get all the way around in radians. How about the radian measure of this? Well, we talked about this would be our 45, 45, 90. So this is at 45 degrees. So what would its radian measure be? Its radian measure, I like to think of it as fractions, So for example, to go 180, it was pi radians, right, at 180 degrees. Well, 45 degrees is how far of that 180? It'd be 1/4. So I'm taking 1/4 of pi. So it's really pi over 4 radians. So it'd be 45 in degrees, and it would be pi over 4 in radians. Let's make sense of this in use of a calculator. So if I popped up my calculator, we're saying that at 180 degrees, we get pi radians, right? So right now, if I look, my calculator is in degrees. So if I typed in the sine of 180, remember sine refers to the y value. So at 180 degrees, sine of 180 is 0, right? Because that's my y value. If I switch my mode to radians, and I typed in the sine of pi, what should I get? I should get the exact same thing. It's saying going pi radians around a circle. So it should say go halfway around a circle. What would its y value be? 0. There we go. So in degrees, 180 is the same thing as pi radians. Okay, so we got to try to start making sense of this here. So let's finish out the rest of these points. So this is at 135 degrees, or hence it's, 3/4 2 pi. So it's really 3/4 pi, or 3 pi over 4. Okay, keep going. So every time I go 45 degrees, how many radians am I traveling? I'm traveling 1/4 pi radians, like pi over 4 radians, right? Because this is pi over 4. Up top is pi over 2, right? Or 2 pi over 4, then 3 pi over 4, then 4 pi over 4, which is pi. So this must be 5 pi over 4 radians at 225. This guy would be 6 pi over 4 radians, which is actually, 3 pi over 2. And this guy would be 7 pi over 4 radians. And lastly, we'd have 8 pi over 4, which we already said is 2 pi radians to get all the way around a circle. Okay, we need to get these down. What about our 30, 60, 90 ones? Okay, so at 30 degrees, how many radians is that? Well, let's kind of break it down again. Every time I go 30 degrees, how many radians am I going? Well, it's pi radians to go 180, and so it's 1/6 of that, so it'd be pi over 6 radians. So this must be 2 pi over 6 radians, which simplifies into pi over 3 radians. Up top would be 3 pi over 6, which is pi over 2. Then we got 4 pi over 6, which simplifies to 2 pi over 3 radians. Are we starting to kind of get the pattern here? So this would be 5 pi over 6, and then 6 pi over 6 would be 180 degrees. And let's finish the bottom. So we want something in degrees. Remember, we use the degrees symbol, right? It's got to have the degrees symbol. When we want it in radians, we don't use any symbol. Okay, on the calculator, we got to flip back and forth between the two modes. So 1 radian would be how many degrees? And vice versa. 1 degree would be how many radians? Well, let's kind of break it down. Let's think of it as a proportion, right? There's a couple ways I could write this. So I could have, radians over degrees equals, pi over 180, because these relate. At 180 degrees, it's pi. I mean, I could also write this as 2 pi over 360. That'd be fine. Or even I could flip-flop. I could put, the number of radians over pi and set it equal to the degrees over 180. Whatever you're most comfortable with. I actually kind of prefer this method. I just like to keep my radians in one fraction and my degrees in the other. Kind of makes more sense to myself. So if I went over here, I got 1 radian over halfway around a circle, so pi equals, well, how many degrees would that be when I go halfway around a circle in degrees? Well, I'd use my cross product, and I'd get pi times x equals 180, and I'd divide by pi, so it'd be 180 over pi degrees, which is approximately how many degrees? Right, because if I multiply 57.3 times pi, I should get 180, right? Our times about 3.14 should be there. Well, 1 degree would be how many radians? Well, I just kind of flip-flop how this works, so now I'm going to find what the radians are over pi, and I'm going to set that equal to 1 degree over 180. So I get pi equals 180x, so this would be pi over 180. And we like to leave it like that. We don't like to write our decimal answers for radians. Let's just see what it would be if I would calculate that. 1 degree goes about 0.02 radians. We like to leave it as pi over 180, right? We like to leave the pi symbol in for radians. So if I were to convert these bad boys, I just like to use that proportion, right? So in this case, I'd have X amount of radians over pi, and I'd set it equal to 40 over 180, 2 pi over 9. Okay, so if we have radians, we like to leave it as pi's. If we have degrees, we'll leave it as a decimal. So in this case, it's pi over 5 radians over pi equals X over 180. So I take my cross product and I solve for X. So if I divide that by pi, that actually just cancels pi's there. So really I have X equals 180 over 5, which happens to be how many degrees? 36 degrees. So you can fill this out. Negative 72, I just still do it the same way. I'll just get a negative radian. And remember, if it's negative, that means on our circle, it's just going this direction. So it'd be going that direction, 72 degrees. So it's basically saying, what would that radian be? I'd get negative something. Okay, we won't go through all that stuff. So how can we measure the length of an arc? Well, we can think of it as a proportion, right? If I set the number of degrees of this arc, right, it kind of matches with this arc here. Well, how many degrees go into a circle? 360. So 120 out of 360, I could set that equal to the length of this arc, if I want to call it L. And what's the length of an entire circle? The circumference. Or we could also write that as what? 2 pi r. That would be the length of a circumference. And to solve for the arc length, this L, I would multiply by the circumference, right? So I'd multiply by 2 pi r. I'd multiply by the circumference. So that's why this says this right here. We're just taking it times the circumference right away. So in this case, we'd go 120 over 360 times 2 pi times 6, the radius. And we would get, well, to do this mentally, this is really 1/3. 1/3 of 6 is 2. So that'd be 4 pi, which is approximately whatever you want. I'm going to leave it as 4 pi as its distance. So if that's how I do it with degrees, how would that change for radians? Well, we'd have radians on top, and what would be on bottom? Well, this is a full circle, right? So we're thinking about the amount of radians, which in this case 120 degrees is 2 pi over 3 radians. And I would put that over what? 2 pi, because that's going all the way around the circle. So it's basically thinking of like the part of the circle over the whole circle. So how many radians for that part? 2 pi over 3. How many radians for the whole circle? 2 pi. And we multiply by the circumference. So in this case, we would take 2 pi over 3 over 2 pi times the circumference, which is 2 pi r. So 2 pi times 6. Oh, what do we notice about this? Let's go take a look at this. If I were to take this formula, this radians over 2 pi times the circumference, which would allow us to find the arc length, well, the circumference is really 2 pi r. And if we simplify this, the 2 pi's would cancel, which would actually leave us with the radians times the radius. That's convenient. So really, if I'm in radians, all I have to do is take the radians times the radius, and I will get the arc length. So it'd be 4 pi units. Okay, so that's much quicker than having it in degrees. So that's where something is useful by being in radians. So if I knew that 120 degrees was actually 2 pi over 3 radians, I could just take it times 6 to find out that I get 4 pi units for the arc length. So if I'm looking for arc length, if I know the radians, it's much easier than having to set up a proportion. And we do the same type of thing for area. Okay, so if it were in degrees, I could take 120 over 360 times pi r squared. So in this case, pi 6 squared. If it's in radians, I kind of have the same thing. Put the radians over 2 pi all the way around the circle times the area of the circle, which would be pi 6 squared. But I bet there's a shortcut. Let's see if I can simplify this. Radians over 2 pi, and the area of a circle is pi r squared. Well, the pi's would cancel, and I could really pull this 2 out in a way, right? I'm really pulling a 1 times radians over 2, which I could pull a 1/2 out, so it's really 1/2 times the radians times the radius squared still. And I think, I always do the radius squared for area. So if I'm looking for the area of a sector, which means the area of this piece of the circle, and I know the radians, I can take 1/2 times the radians times the radius squared. So this is 36. Half of 36 is 18. And 18 times 2 pi over 3 would give me 12 pi units squared. So if I know my radians, the math is a lot easier, and I don't even have to rely on a calculator or setting up proportions or anything like that. So remember, for sector area, the area of a piece of a circle, we take 1/2 times the radians times the radius squared. So we got a couple Ferris wheels because those are the shapes of a circle. So we can describe their speed in a different way using radians. So knowing how long it takes for a rotation is important. And we're going to describe what we call angular speed to find the speed moving throughout a circle. And we're going to use radians. So what happens to be the angular speed of this Ferris wheel? That's 160 meters high, of the star of Nanchang, and it takes 30 minutes for one rotation. Well, angular speed is going to be calculated using radians per minute. Well, if I think it takes how many radians to get around a circle? 2 pi radians, and it takes 30 minutes for one rotation, so it takes 30 minutes to go around a rotation. And if I want the speed in radians per minute, well, it takes 2 pi radians to get around the circle, which takes how long? 30 minutes. Right, so I got the radians on top, minutes on bottom. That would simplify to pi over 15 radians per minute. This would be the angular speed of this. If I wanted to calculate how fast a person was traveling, then I would have to take into the circumference of the circle. I'd have to take into the diameter of this guy to figure out how fast that person was traveling, and we'll look at that as well.